Hi. So it's beginning of February 2022, and what I have here is a refractory kiln or oven, basically a charcoal making thingamajig. The basic design or concept for this particular model was inspired by a video I watched a few years ago by a guy named Bob Wells, the owner of New England Biochar. When I made my first one, I made several modifications to make it more efficient and function slightly differently than the one that he showed. And this is the second one I've made now. I've made some minor changes to the second one, which I'll discuss when I show you how to make it, to make it work a little bit better. Before I get into how to make it, I just want to say I'm not a big believer in it's simple, it's easy, anybody can do it. All right, no. You will need some tools, you will need some skills, and you will need understanding to make this produce charcoal efficiently. And I believe for a small scale charcoal production, from the various ways that I've seen people on produce videos and say this is how they do it, I'm pretty convinced that this is the least polluting and the most efficient as far as fuel wood ratio to the wood that is going to create the charcoal. I would just like to also say that this is you know, it's not dangerous. Fire's not dangerous, okay? Fire is fire. And when it becomes a problem is when you don't respect it, okay? This thing, it hasn't quite fully heated up yet. It's not gassing at full capacity yet, but it gets pretty hot, and it can cause things to light on fire or smolder if it's close enough. So respect fire, and and respect some other things that I'm going to talk about as I explain how to make it. So I mentioned understanding. I just want you to know what I mean by that. In my video, there's some things that I'm not really going into detail, on, maybe welding and drilling holes and stuff like that. Those are some basic skills that you're going to have. This is not something you make when you're learning how to weld or you're learning how to do use the basic tools and stuff that you will need to make this. What's important is I want you to understand clearly how this refractory kiln or oven is supposed to function, and kind of what's a little bit of the science behind it, so that when you go to do this yourself, that if it's not working perfectly, or all the wood inside didn't cook, etc., there's a bunch of things that can, I wouldn't say go wrong, but not give good results. You need to understand so that you can figure out what you did wrong or what you have to do differently. So that's very important. The other thing I'm going to say also is I'm going to do a video on biochar. I'm probably going to call it Biochar 101. There's just this crazy debate between all different factions of how great it is, how it's, you know, it's nothing, it's not doing what everyone says it does, and so on. And I found even with some people who are promoting biochar, they're not really getting into the fundamentals of what it is and how it actually works and how it interacts in the soil. So I'm going to do that. And the other thing is, so when I made my first oven, I was processing the charcoal by hand with a hand crusher that I made, and that was very tedious. I have developed a little machine, well, a man-powered machine that grinds this stuff up very quickly and does a very nice, good quality job. And I'm going to do a video on that also, so that you could possibly not have to do it all by hand like I did the first 50 batches. So let's get on with how to make this. Anymore. Anyways, I'm not I'm not sure what they are by gallons, but just so that you can be certain, if you go to make your stove, I'm going to give you the dimensions of these two barrels. So the outer barrel is 34.5 inches tall and 22.5 inches in diameter. And the smaller one, which will go into the larger one, is 29 inches tall and 18.25 inches in diameter. So the first step that is going to be done is, let me get my marker here. So the large barrel, you're going to cut the top off, the top that has the holes for filling and emptying, and we're going to cut it off 1 inch below the lip here for the end. And the smaller barrel, we're going to cut off on the inside. We're going to cut the lid with the holes and remove it, and then grind the edge smooth so you can't cut yourself on it. So that's step number one. I forgot to say that I'm using an angle grinder to cut. You may, if you don't, well, I mean, if you don't have an angle grinder, you could possibly use a jigsaw with a metal blade, but you're ultimately going to need a grinder anyways, because there is grinding to do afterwards. So the small barrel, okay, there's the lid, there's the end with the holes. Don't really need that unless you're going to use some of that metal to close the holes off on this barrel. Okay, so on the big barrel, we have cut the top off. There's an inch lip here. You'll see why that's needed up eventually. Some perfume in here. So you got to take the plastic covers out and cut a round piece of metal and close both of these holes off and weld it. So that's the next job on this one. On the large barrel, the outer barrel, I'm going to, this is a 1 1/8 hole saw, and what I'm going to do is I'm going to put 8 holes in the bottom, with the center of the hole being 2 inches from the bottom, and I'm going to put 8 holes in here, equally distanced or equally spaced around the barrel. Okay, so here's the outer barrel. There's 8 holes, 1 1/8 inches in diameter, roughly evenly spaced around the bottom, and the center of the hole, as I said, 2 inches from the lip here. So put that aside for a second here. This is the top of the outer barrel. I cut little pieces of metal to fill these holes and welded them. So two things. First of all, you could actually make this without needing a welding machine. I'm not going to show you how to in this video. Maybe I would do it in the future, how to do this without welding. I choose welding, but I will just give you a couple of heads up. These lips, when these barrels are put together, the round part is welded with the seam, and then the ends are put on and crimped, and there's a seal or sealant in there, and it'll burn if you weld there. These two caps with the threads for the plugs, these were also crimped on. Some of them are solid metal. These ones were crimped on, so when I was welding it, the material started on fire, popped holes through the metal, and create a lot of really toxic fumes. So just be aware of that. Make sure you've got good ventilation. So the next step, I went ahead and got a little ahead of myself here. The next thing you need to make is you're going to attach regular stove pipe, or even if you want, you can use ventilation pipe, cold air pipe. But what we need is a metal ring that this will fit onto. Okay, I do it this way. If you want, you can actually buy a short piece of pipe with the crimped end and a straight end, and you could use that. I work on a low budget here, so I make my own. I just, this is probably 16 gauge metal. I just cut it to length and width, and then I just form it by hand using a piece of pipe. Just give you a hint here. You get this into the pipe. Make sure it fits as snugly as possible into the pipe. And what I do is I then clamp this carefully with a pair of vice grips. And then just be careful with it so you don't, it's only clamped on one end, so if this expands or contracts while you're handling it, then it's going to change, it's going to make the diameter smaller here. So just be careful how you move it. The other thing is make sure you make a mark as to which end, or so that you know which end was in. So when you go to cut the hole in the top, which is where it's going to go, you use the bottom, not the part that was in this pipe, but the other end, because it could possibly be a different size, too big for this to fit onto. So when you put it in the wrong and you've welded it on the inside so you can no longer change the shape of it, then you're going to find that the pipe doesn't fit. So just to avoid a headache. So that is the next step. I'm going to weld in here a little bit. I do it that way you don't have to do any grinding on the outside. And then I'll mark and cut a hole and then weld it into the lid. So, okay, so my piece is installed. I just put it, I don't know, 6 or 8 tack welds in the bottom. You don't need to weld it in solid, simply because with the chimney drafting out, you're not going to get smoke puffing out of these holes, so it's not necessary. Let it protrude inside, but not too far. I've got about 1/2 to 3/4 of an inch there, and then the non-furrowed end fits on there, and eventually in my setup here I'm going to have some pipes inside, and then it's going to go outside. So that part is finished. There we go. Put that aside for a second. So the next thing that we need for the lid, and I've simply salvaged the ring, the parts that I made that are on the barrel that is crumbling apart. These were not exposed to the direct flame, so they didn't oxidize and crumble. So I'm going to reuse them. And basically, you're going to understand better once I put this together and get it on the outer barrel, and then you'll understand what this is for. But basically, when I made it the first time, I just improvised and cut strips of metal that are, what do you get, my measuring tape here. These are 3 inches wide, so I cut some strips of metal, 16 or 18 gauge metal, 3 inches wide, enough to go all the way around, and then I tack welded them together. I'll explain that better once I get this installed, and I'll show you on the barrel. I didn't make this as good as I could have, and I'm going to improve it, and then I'll explain that again once it's together, once I can show you on the barrel. But basically, you'll see there's holes in here and some notches cut out. You don't do that ahead of time. You start with 3-inch strips of metal, and I won't tell you any more until I get this put together, and I'll show you on the barrel. It'll make more sense. Yeah, so I forgot to explain the details about this ring, the 3-inch wide ring that I was talking about. So the basic function of the lid is it has to turn. That's why these wedges are cut out of the strip of metal, and there's 4 pins welded on the outer barrel. It's just like quarter inch 5/16 rod. And what I did, I put the lid in place. I marked the profile of the notches after I made the notches, and then put each pin on using the marks that I made. Because I made this ring and it was improvised, these little notches are not evenly spaced. So I welded a nut on the ring and on the barrel, just so when you go to put it on, you know how to orient it, and you're not messing around with it, not once you've got it lit and if it doesn't close. So the idea is when it's open, there's holes drilled all around, and air can get in here, and when you light the fire, because the fire burns from the top down, it allows air to get in here to get the top of it burning and really hot, so that when you put it down, the drafting of the air, the hot air leaving through the pipe, it starts to draw in cold air at the bottom. Now, I will tell you, I've made improvements on this. I made this ring in 4 pieces originally, which I basically just cut my 3-inch strips. I put the lid down, and then I just held it in place and tack welded it to the top, because there's a 1-inch lip here that we left. And I started tack welding it, holding it against the barrel, welding it, holding it against the barrel, and then where the pieces overlapped, I just tack welded them here. So on the first model, what happened is on the first one, this ring was up against the lip here. And what happened was when I turned it to close it, because the part of the barrel, it didn't seat perfectly with the barrel, so the holes were too close to that joint, and air was still getting in at the top. So when I reattached this ring, I put it much lower so that when I close it, it's as sealed as possible, so that very little air can get in through the top anymore. The other thing I did that made it difficult was, I showed you, I just started laying the metal along the barrel and tack welding it on. And what happened was the inner circumference of the strips of metal was pretty close to the outer circumference of the barrel, and it wasn't too difficult to get it on when the barrel was unused. Once I burned it, several times, the barrel began to become distorted. So before I reattached my ring from the other barrel, what I did is I cut these spot welds here, and I bent them so that these would be further apart. And what that did is it now the strip there is more conical or flared. Okay, so there's quite a bit of space now between the band of strips of metal that I put on in the barrel, but because it's touching at the top, once you turn this and it goes down, and where I cut the barrel off, it's pretty close there. It's pretty tight. It's pretty sealed because it's conical. So that is the difference. And as I said, it's going to be a lot easier especially if the top lifts off from an explosion, and you've got to get it back on there, and you can't really mess around too long because it's really hot. So yeah, so that's the strip of metal. Just to let you know, when it's open here, there's about 18 holes, half-inch holes that I drilled. Well, I drilled more than 18, but right now there is 18 holes that are fully open when the lid is open, and that seems to be the right amount of air to get that fire going on the top. The other thing I was talking about when making this ring here, about it needing to, fit this elbow easily. So I've got my pipe attached. So when you go to turn it and close it, this needs to be able to turn so that it doesn't knock your pipes apart. Or at least that's the way I have it set up inside. So now we're going to finish the inner barrel. So here's the end that we cut out with a little bit of lip remaining, just to give it some extra strength. That's why I leave that there. So basically, the inner barrel will get filled up with the wood that is going to make the charcoal, and then we're going to make the lid here now. A lid's going to go on it, and then the barrel will be turned upside down and put into the outer barrel with the sealed end up. Just want to talk quickly about the integrity of the inner barrel, and this is really important. There can't be any holes anywhere, above the bottom, simply because when the charcoal is, when the wood inside here is cooking, it actually is red hot. And if any heat could escape out of a small hole or something up here at the top, then once the burn slows down and stops, then heat could come out of that hole and draw oxygen in, and basically your charcoal is going to smolder and turn into white ash. I did have I've cooked well over 50. I didn't count. I should have counted. I made quite a number of batches in the first oven that I made like this, and I did have one that ended up turning into ash as it was cooling, and I don't really know why. It was just a fluke. Somehow air got in at the bottom and it just kept smoldering. But yeah, that's just the importance of the integrity of the inner barrel. What I'm going to use for the base here is quite a bit heavier than the metal, the thickness of the metal of the barrel. As I found with my first unit, that this bottom piece doesn't seem to disintegrate as rapidly as the barrel material. So I'm going to use slightly heavier material on this model with the idea that when these barrels become unusable, that I'll be able to use this base on the next barrel. So basically, what I'm doing here is I'm going to place the barrel at the corner of this sheet of metal, and let me see what my measurement is. And on these two sides here, the barrel's going to be in 1.25 inches and 1.25 inches over here. And then I've already drawn it, but I'm going to draw the profile of the barrel with a Sharpie. Okay. And that's where we are going to cut out the lid. And what you're going to do is you're going to equally distanced around. You're going to create 4 tabs. They're going to be the 1.25 inches by, what I have here, 1.5 inches. So you're going to make 4 tabs, equal distance around this profile. So when it gets cut out, so I went ahead and did everything. So when you cut your lid out, the line that you draw, it's stay at least 3/16 to 1/4 inch away, so that this sticks a little bit past the barrel, just to give it a little bit of extra life. So what I did was I cut out the lid. I bent these tabs down. I drilled 5/16 inch holes in the same place on all 4 tabs, and I marked that out when it was before I bent it, obviously. And then I bent it. I bend it on the barrel. You can bend it in a vise or with a pair of pliers, but I like doing it on the barrel. That way, the bend ends up exactly at the profile of the diameter of the barrel. And so how these tabs work is what I've done. So I've done this barrel differently than the other one. In this barrel, after I set this on with the 5/16 holes in it, I drilled 5/16 holes into the barrel, and then I put a bolt from the inside out and welded all around the head of the bolt
to secure it into place and make sure no air can get in there. The first one, I actually put the nuts on the inside and then put the bolt in from the outside. And what I found was after a while, occasionally something would either get deposited on or the threads would distort, and then it was hard to get the bolt. One eventually broke off. So I'm doing it this way, hoping that if threads do get slightly messed up, that I can clean it before I take the nut off so I don't break the bolt off. So the lid basically works. The bolt sticks out of the lid just enough to get the nut on there. It doesn't have to be tightened down. It's just to hold it into place while you're lowering this into the outer barrel and taking it out afterwards. So I have these tried. Okay, so there's the lid with the tabs. I'm hoping that these holes are equally distanced apart so that this lid can go on in any position. It wasn't so with my last lid, and I had to do the same thing, put a little marker on so you could orient it. There you see I put the bolts in. The bolt head is on the inside. I welded around it. And oh yeah, also on the which is technically the top, I just took some rod, thin, what is this? Looks like to be about 1/4 inch rod, and bent it and made 2 hooks because I use a little chain here that I hook, and this allows me to lift this up and lower it into place, and then take it out afterwards. So it's a lot easier than just trying to grab the barrel, particularly when you're putting it in and it's full of wood. I used to just drop it in there, and I think it just caused a lot of distortion and things in the base. So this chain idea is a much better idea. So when we fill this up with wood, the other thing too is after I drilled these holes using the holes in the lid as the guide, I re-drilled these holes to 3/8, a little bit bigger, so it's going to be easier to get these on and off. So you fill it up with wood, put the lid on, put the nuts on, and you're ready to go. And the gas will come out of where the base meets the barrel. This is a different design from the first one, and I'm pretty confident it's going to work. In the first one, I had bent the base over like these tabs all the way around and drilled some holes in the bottom. Now, I don't really like the way it caused distortion and buildup of creosote on the plate and in the bottom of the barrel. I believe that this area around the base is going to be enough to let the gas out. So you're gonna, when I fire it up later, we're gonna see if this works. If not, what I might have to do is drill a few holes around the outer edge. But we will. I'll give you the results there after we've burned it and inspected the quality of the charcoal that's inside. That'll tell us a lot. Okay. Aside from that, all right. So now we're ready to fill up the inner barrel with wood that is going to produce the charcoal. And after, I'm going to talk about filling up the outer barrel. But first, I would like to give a little context of how I'm doing this and why I'm doing it the way I am doing it. So my first refractory oven I made in 2019, and I think it was late in the summer, and I ran it a couple of times, and I was really happy with the results. And but I noticed that the amount of heat that it produced was a lot, and I thought to myself, I wasn't ready to use any biochar in 2019, so what I decided was I would wait till winter, and when I didn't have as much work to do outside, that I would bring it inside in this workshop and heat the workshop. And because the wood that I was using was stored outside and not necessarily covered up, I would at least use the heat energy to first of all heat the workshop up so I could work out here, and also dry off the wood that was wet from being outside. Now, the first thing I want to talk about is I'm going to use two different terminologies here when talking about wood: cured and dried. So when I say that I brought wood in here to dry it, that would be wood that was already cured, and I brought it in here to dry it off from water, from rain, or ice and snow or whatever. And what is the difference between the two? I'm still surprised as to even people who heat their homes with wood don't know the difference between the two. So when you cut down a tree has a certain amount of free water and a certain amount of fixed water. And the free water is like when you cut it down, you see sap coming out. The free water is running through the veins, if you want to say the capillaries of the tree. And the first stage of drying wood after you cut it is that free water leaves those capillaries. And the second stage, which is curing, is there's a certain amount of water that is fixed in the cells or the fiber of the wood. And once the free water is out, then the water begins to leave the cells or the fiber of the wood. And that process does take a while. So the wood that I'm going to be using today has been dried because it was outside, and it's skid wood that I'm using, but I'm confident that it has been cured. Skids often spend their time in warehouses, so when they're made, the wood is not cured, simply like construction wood and the wood that they use for skids. There's a much higher percentage of humidity in that wood than there would be in, say, wood to make furniture. The reason being is when you build things with wood, whether it be the frame of a house or a skid, it needs a certain amount of moisture in it, so when you put nails and screws through it, it doesn't split the wood. So if you picked up a skid that was freshly made, there's a good chance that wood is not fully cured. But if you're picking up scrap pallets that have been in warehouses for a considerable amount of time, you can be really confident that wood is fully cured. And as what happens here is in the wintertime, I'm picking this stuff up and it's wet from snow and ice and so on and so forth, so we dry it. So it's very, very, very important for this refractory oven or anybody that's making biochar is that you're using, first speaking about the wood that's going in the inner barrel, has to be fully cured, because I don't know if you're making one of these or if you're looking at it, you're going to see that the space between the inner and outer barrel is very limited. Okay, so we're not burning a lot of wood on the outside of this inner barrel to get this wood heated up to the point where it begins to gas, and then having the gases come out and burning and helping to continue to heat that wood. So if you're using uncured wood in your inner barrel, it's just not going to gas, or it will be partially charcoal. In other words, the outer part will be charcoal, and then when you try to break it up, you're going to find that the wood, it's still wood on the inside. So that's really important. I know that again. I'm gonna talk about what kind of wood you're putting in your barrel, the ratio of hardwood to softwood, how much hardwood and softwood are you putting around the outside. This is all you can calculate all of this, because softwood, hardwood, different kinds of wood have a certain density, and that you can calculate how much potential energy it can produce when it's burning, how much heat can it produce. At the same time, you could measure the density of the wood, or calculate how much heat it needs to heat up the wood that's in the inner barrel to get it to gas. So I'm doing this, it's kind of guesswork in a sense, but after doing quite a number of burns, I kind of have a feeling as I'm loading this inner barrel, how much of it is hardwood, how much of it is softwood, and then how much hardwood compared to softwood I'm putting around the outside. After doing a few loads, you kind of get a feel of it. What's really important to me is to do this efficiently. I don't want, if you're using uncured wood, you're gonna have to burn it twice. How much pollution, how much negative effect do you want to have to produce a little bit of biochar, which in the long run will have a very long-term positive effect. Okay, but I want to be somewhat conscientious of what I'm doing and how I'm affecting the environment, because I'm making biochar to improve an environment, to improve food production, and so on and so forth. So I'm just going to give you a couple of examples, and I don't have all the different kinds of wood that I normally process available to me right now. I'll give you some idea. So I would say to give you the best advice I could give you right now is, on your first few loads that you do, your first few burns, make it 50-50, 50% hardwood, 50% softwood, no more, no less. Again, environment, climate has a huge effect on what's going on. I'm doing this in the winter, so the wood I'm putting in here, even though I'm heating this workshop, is cold. Okay, so you need that much more energy to get it heated up to gas. So how would that affect things? Well, okay, if I was doing this in the summer when the wood was warmer, I could up the ratio of hardwood slightly. Remember, hardwood is much denser than softwood, so it's going to take more energy to heat that wood up. And in the winter, I might reduce the ratio of hardwood to softwood. The other thing is the size of pieces. Okay, so this is a softwood 2x4 that I'm sure is cured, and it's about 6 to 8 inches long. Okay, that's perfectly okay to drop in here. If this was a piece of hardwood with the same 2x4 dimensions, I would want to cut it in half, okay, just to make sure that there's enough air and heat circulation around to get it heated up. Now, again, so when you're loading this, so these are pieces of softwood. These are 4 inches, 6 inches, 6-7 inches long. That's perfectly fine. As you're loading this, there has to be sufficient space in between the pieces. Okay, you can't place them and get it all tight together, because you need the hot air to circulate, and then as it starts to gas, you need the gas to be able to easily get out the bottom. So it can't be tightly packed. But if you just start dropping these pieces in, you're okay. One thing I've done in the past, and it's worked quite well, is when I'm using hardwood, whether they're hardwood. Some of the hardwood that I have available to me that is not from trees, okay, comes in 2-inch by 3-inch or 3-inch by 3-inch. So again, I would cut them in pieces that are 3 to 4 inches long, and then I would drop some in, and then I would take longer pieces of softwood and kind of place them in there, just to ensure that there's a certain amount of space maintained in between the pieces. A piece of softwood like this, if it's this long, no problem. It'll cook without any trouble at all. A piece of hardwood like this, well, if it was thinner, some of the skidwood here, some of the hardwood pieces are half the thickness of this, which this looks to be approximately 3/4 of an inch thick. So some of the hardwood is less than that, and you could put a piece this long of hardwood in, but if you have a piece of hardwood that is 3/4 of an inch thick, once again, you'd at least want to cut it in half. Okay, so this takes a bit of experience. Again, for me, I want to maximize the wood that is in this inner barrel compared to how much heating potential is in the outer wood. I want to make sure that I'm getting the most out of each burn. Clearly, here's a piece of firewood. This is a piece of pine. This is not okay. This will not cook at all. You could leave it this thickness, but you'd have to chop it into slivers and pieces that are, no more than 1 inch to 2 inches thick. As I said, different woods have different gas potentials, but another thing that you need to consider is, particularly in pine. Pine has a lot of heavy sap in it, okay, and for heavy sap to dry out and break down takes a very, very long time. So spruce, this is all spruce from skids. This is actually pine. This feels extremely light, so I'm pretty confident that the sap has degraded quite a bit. But if you're using the sapwoods, and like I said, especially pine, you have to take into account too that the heating process that's going on the outside of the barrel, the pine is going to need a lot more heat to get that sap out of the wood and into gases. So this is something that you have to, like I said, you have to run a few batches, and to me, I start getting a feeling of when I start chopping stuff up. Okay, I've got this much hardwood. It's time to throw this much softwood in there. Blah blah blah. What you want to make sure is that when you're done, you've got your spacing. That this barrel's filled up, so when you turn it over, you're not getting a big empty space at the top of the barrel, because you want wood as close to the top as possible, so that as you light your fire and the fire is burning on the top of that barrel, it's starting to transmit some of that heat into the wood that is inside the inner barrel. Okay, so I've got the inner barrel loaded and the cover or the lid put on. So what I'm going to do is I'm going to lower this into, that's quite heavy. The outer barrel. Okay, so what's happening here? The outer barrel's not placed in its proper place. I have some other things that have to be done before we can light this up. But what I'm going to talk about right now is the fuel wood, the wood that's going to burn to heat up the wood that's in the inner barrel that's going to make the charcoal. So this is, again, a thing that needs a little bit of understanding and thought put into it. Okay, so I'm gonna get some pieces of wood here ready. So what you have to keep in mind when you're loading the wood in the between the inner barrel and the outer barrel, the purpose of the wood that you put in here, as I drop this in. So the purpose of the wood that is burning, okay, so it has to burn hot enough to get enough heat going into the inner barrel to heat up the wood so that it begins to gas and burn. The gas begins to burn and add to the heating process. So it has to be hot enough to do that, but it also has to burn long enough to make sure that that process is fully underway. So I had a couple of burns that didn't work well. For one, one of the things that happened was, if your fuel wood, if there's too many small pieces around here, what happens is there's more surface area, so there's a hotter fire because there's more fire, but it burns quicker, and the fuel wood burns away before the inner wood is at the right temperature for it to gas. Okay, and I've had the opposite experience also, where the pieces around the outside, there were too many big pieces and there was less surface area, meaning there was a lower temperature, and it just was not enough to heat up the inner wood hot enough to get it to gas. So it's kind of a balancing act here. You have to have enough heat burning around the outside of this inner barrel to get it to begin to gas before all of the outer fuel wood is gone, because the outer fuel wood helps ignite the gases as they come out. So what I found is, in particular, when I'm using skid wood, this is a piece of hardwood. So what I found was, I have a minimum of 4 pieces of hardwood like that, which are basically a 2x4, and 4 pieces of softwood. Also, that is enough to make sure that this process functions properly. Now, what I found is, look, sometimes you don't have a thick enough softwood or hardwood. So what you can do is you can take boards like you take 2 softwood boards, double them up, and put them down in there. You could take 2 hardwood boards and double them up and put them down in there. As long as they're close together, then you're going to have less surface area and you're going to have a slower burn. Once you get those pieces in there, you can put smaller pieces in between those, the thicker pieces that are burn longer. You can put smaller pieces in there, but what you have to be careful of, and I'll just use an example of. So let's say you start dropping these smaller pieces in between the tall pieces. What you want to avoid is the pieces getting in here and ending up like that. You want to get them as close together as possible. You want to ensure that there are not big open spaces in between the pieces of wood, because, as I said, it requires a certain amount of heat and longevity to get the inner barrel to begin to gas. So I've started putting the wood around the outside. Pieces like this one are long and wide enough to fill most of the space in between the inner barrel and the outer barrel. You can see I've doubled up some thinner pieces here and here and here. Okay, and basically what you want to do is try to fill as much of the space as possible with various size pieces. And once you've filled the spaces around the outside, what you want to do is ensure that as you start to put wood on the top here, okay, what you want to ensure is that you have enough either hardwood or thicker pieces of wood that are going to not fill in the space, but be over top of these pieces of wood that go around the outside, because they need to ignite. You need to have a fire burning above this piece of wood long enough to make sure that wood ignites and starts to burn down. Because remember, the process here is counterintuitive, where heat rises and fire burns up. We're doing the opposite. We're getting heat to build up in the top and then burn down. So okay, so I've got this set up in here, and I'm ready to do the first burn. Just keep in mind the first burn on this, with the paint on the barrels, the paint on the inner barrel, is going to be very toxic. You don't want to be you don't want to be around this when it gets going. And as I was saying, like, I was using the charcoal refractory oven to heat my workshop. Yes, but not on the first burn. The first burn is really bad. You gotta get all this cleaned up. So I'm gonna light this up now.
Okay, so we're about 5 minutes into the burn. I had to leave the building because there's too many fumes because all the labels and paint burning off of the top of the barrel, and the galvanized coating off of these ventilation pipes burning off. But the fire is doing very well just in the top, and it's probably going to take about another 10 or 15 minutes before we close the top down. So we'll get back to you. So the fire's been burning for about 15 minutes now, and this is kind of a cheat because this is the first burn. So you can see that the paint is beginning to blacken below the level of the inner barrel. So what that tells us is the wood that's between the inner and outer barrel is beginning to burn, and it's beginning to burn off the wood. So at this point, it's time to close off. I got my welding gloves on because this is really hot. It's time to close this off. We no longer need air coming in through the top. It's hot enough so the I don't know, the air velocity going out is going to draw in cold air through the bottom, and it's going to keep that fire burning. So it's about the right time to close it off. Okay, so we are about a half an hour into the first burn. If I don't die of the paint fumes and toxic fumes in this workshop here, then it'll be good because I'll be able to continue to show you what's going on. But you can kind of see the light flickering out of the side there, and you can hear the noise. Okay, so what's happened is the inner barrel is continuing to heat up, and there's a lot more gases coming out, and it's starting to burn hotter. We haven't got heating up all around yet. There's still some paint here that hasn't been burned, but so far this upgrade from the first one is actually performing better. So I'm pretty impressed. I'm pretty excited about what's actually going on here. Okay, so here we are. I'm gonna open this up and see take a look at the charcoal that we made. Just before I do that, this has been sitting overnight because the burn we did in the video was last night, so it's had lots of time to cool off. It's very important that before you take the inner barrel out and open it up, that it's completely cooled off. Otherwise, as soon as the hot charcoal, if there's still any red hot ember in there, any charcoal in there, as soon as it gets air, it's going to smolder, and I've had that happen to me once. So I generally let it cool down at least 3 hours before I take it apart. In the winter, that seems to be enough. So, there we go. Keep the ash and embers that charcoal off the top of the stove. Pull this over our chain. See, still got some creosote on the bottom, even though I don't have the holes in it, so ratchet.
that slightly. With these tabs, you just want to move them just enough to get it off. If you bend them back and forth too much, eventually they're going to break off before this bottom piece is worn out. I just heard some metallic shale fall off the outside of the barrel here. That's why these things will wear out, is because it gets red hot and the metal oxidizes and slowly gets thinner and thinner. Some problems getting this off. Probably have to make these holes a little bigger than 3/8. Off. You see right off the bat, one of these lower pieces of charcoal here has a little bit of white on it, so there was a little bit of smoldering and a little bit of air getting inside afterwards. So you can see the charcoal is down here, down to this level, so there's a lot of shrinkage. So this is our cooked charcoal, and as you can see, it's well done. If you were to break some of these pieces, if it wasn't cooked, you would find that it wouldn't break apart very easily, or you'd start seeing something that looks more like wood. So this is a perfect batch. So I just also mentioned, I think earlier, that there's some things that I've done to make these barrels last a little bit longer. And one of them is, obviously I'm burning it indoors, which, remember, you gotta treat this with respect. This gets really hot for a really long time. The total burn average, depending on how much hardwood is in the inner barrel, the total burn can take up to 3 hours, and it tends to get red hot all around the base here. So anything within a 1.5 to 2 feet has a like, if you have wood nearby, it can smolder. I've got it up on bricks, so it's not touching the ground, to keep it dry, so that it's not drawing humidity out of the ground. On the other one, I actually put an extra sheet of metal underneath because it got so hot under there that this is a dirt floor here, and there's some tree roots growing through here, and after a few burns, the tree roots and stuff started smoldering. So it gets pretty hot down here too. I don't, if I store this outside, I make sure that it doesn't get rained on, because any water, humidity getting on this is going to make this metal rust a lot faster. So yeah, when I loaded this and showed you putting the wood into the inner barrel, and then what it looks like when you load the outer barrel, I'm using skid wood, but you can use a lot of different materials, especially when I do firewood production. I've found a new use for all the branches and the smaller pieces of wood. As I explained when I was loading it, what you have to be conscientious of is the density of what you're putting in. So, when Bob Wells showed how to make this in the first, when I watched his video, he was talking about, you couldn't fill the inner barrel up with wood chips. It's too dense,
And as I said before, there has to be enough burning energy, heating energy from the wood on the outside to get the wood on the inside cooking. One thing I found, I'm doing this in the wintertime, I change the ratio of hardwood to softwood in the inner barrel when it's really cold. When it's warmer, you'll find that you can put more hardwood in the inner barrel, or you can cut the pieces smaller to get them closer together. It's something that you'll have to have some experience with after you've done a few burns and you see how it works. You can make that adjustment, because after all, efficiency is very important. I don't want to run the oven and do a burn and then have very little charcoal in the inner barrel at the end of it. So that's really important.